Okay, lesson 10.2, actually the last lesson in this chapter or unit of study, solving square root equations. So the core concept, we're going to be squaring each side of the equation. If two expressions are equal, then their squares are also equal. So if you had a is equal to b, then a squared is equal to b. So in a radical equation, it's an equation that contains a radical expression with a variable on the radicand. To solve it, we need to first use properties of equality to isolate the radical on one side of the equation. Then use the, like inverse operation of taking the root, which is taking the square or squaring both sides like we saw right here, and solve for the variable. So this is that property that we're talking about. So here we go. Solve the equation. The first thing we're going to want to do is subtract 5 from both sides because we want to isolate the radical. So we get square root of x is equal to 8. Then we can square both sides of the equation, right? Using the inverse, that's the inverse of taking the square root. So we'll get x is equal to 64. That kind of makes sense. You can check your work and so forth here. So we want to first, looks like since this is 0, we could add the square root of x to both sides. You could always, subtract 3, then divide by a -1, things like that. We're working with equations, nothing reverses. But when we're left with 3 is equal to the square root of x, we want to take the square of both sides so that we can get x out from under the radical symbol. 3 squared is equal to 9, and the solution is 9. All right. Sometimes we have to do a little bit more work. Like here, we would subtract 3 from both sides. Then we would divide both sides by 4 to get this, radical expression. Square this will give us x plus 2 is equal to 16, and then we still have one more step. We have to subtract the 2 from both sides. So let's give these a try. Here, it's already isolated. We are going to square both sides. So x is equal to 4 squared or 16. Okay. A little bit of work that we have to do here. We want to add 3 to both sides. All right. So we'll get 11 is equal to the square root of n. Now we have the radical alone. We can square both sides to use the inverse operation of taking the root, and we get 121 is equal to n. Okay. I will let you do number 3. Pause the video. Hopefully you got that a was equal to 9. Number 4. Number 4, we will subtract 7. So we get the square root of s minus 3 is equal to 4. So now we're going to take and square both sides. We'll get s minus 3 is equal to 16. So we'll add 3 to both sides, and we'll get a final answer. S is equal to 19. And of course, because we're working with these equations, you could go back in, substitute it in. You'll have, 19 minus 3, you get the 16 under the radical. When you evaluate the square root of 16, it's 4. 4 plus 7 is 11. So you can always check your work. So go ahead and give number 5 a try. Hopefully you got t is equal to 6. And let's look at the last one. So we'll start by subtracting 2. 3 square root of 3, x minus 6 is equal to 18. Then we can divide both sides by 3. That gets rid of that 3. So we get the square root of 3x minus 6 is equal to 6. So we're going to square both sides. Okay, so that's going to give us, I'm going to try to write it over here, 3x minus 6 is equal to 36. We're going to add 6 to both sides. So 3x is equal to 42. Finally, divide by 3. And x is equal to 14. And you could check your work. There we go. Okay, for this final example, we're going to be doing some real life application. So right here it is saying, oops. Basically, the period p in seconds of a pendulum is given by this function that p is equal to 2 pi times the square root of L over 32. L is the pendulum length, okay? A pendulum has a period of 16 seconds. Is this pendulum 16 times as long as a pendulum with a period of 4 seconds? Explain your reasoning. Well, we're going to need to do a couple calculations, okay? First of all, we're going to need to calculate the length for, because we want to know if it's 16 times as long. We'll need to calculate the length for the pendulum with 16-second period and a 4-second period. So that's what this is. This is the p in seconds. So we'll replace p. So we start out with, I'll do it up here. 16 is equal to 2 pi times the square root of L over 32. All right, we want to get this radical by itself, so we're going to divide both sides by this 2 pi. Okay? Okay. Once we do that, then we're going to square what's left, right? We'll square both sides, basically this. So that we have 16 squared all over 2 pi squared equal to L over, I don't know why, that doesn't look like an L. Does that look like an L? No, it does not look like an L. L over 32. Okay, to get rid of 32, we have to undo the division, so we're going to multiply both sides by 32. And now we need to do some number crunching here. We've got 32 times 256 all over 4 pi squared. Okay, so that's 32 times this 256, that's 16 squared, and then 2 squared is 4, and pi squared. Now I'm just going to leave this down here for a minute. All right, this is going to give me like 8,192 over 4 pi squared, and that's even and that's even. So if I took that 8,192 and I divided by 4, I could simplify a little bit and work with a smaller number or smaller value here and get this 2,048 over pi squared. And you'll see why I'm leaving the pi out of it, because pi is irrational, non-terminating, non-repeating. So let's just leave this value for now, okay? And that's going to be the length of the period of 16 seconds. So now we want to come over here, and if we have a period of 4 seconds, we'll work the same equation, 2 pi times the square root of L over 32, dividing both sides by 2 pi. Okay, cancels there. Squaring what's left. Hope this doesn't confuse you that I'm kind of combining steps here. So we'll get 4 squared over this 2 pi quantity squared equal to L over 32. And then I'm going to multiply both sides by 32 to get all by itself. Okay, so 32 times 16 all divided by 4 pi squared. And again, we can simplify. And if I go ahead and multiply, divide by 4, I'll just kind of take that step out. I will get to 128 all divided by pi squared, and that's equal to L. What I'm wanting to know if this number is 16 times as long as this number. So, two options. Multiply this by 16 or take this and divide by this, right? So, let's do some fancy division here. So if we do 2048 divided by 128, right? That equals 2048 times the reciprocal, so that we can cancel out our pi's, cross cancellation. Now we're taking 2048 divided by 128, which is 16. Okay? Also, if you multiplied 128 times 16, you would get 2048. Of course, this is still over pi squared. That's over pi squared. So, simply, the answer is yes. A pendulum. With a period of 16 is 16 times as long as one with, I'm shortening this, period of 4. And these are seconds, 16 seconds, 4 seconds, 16 times as long. Yes. So the answer was yes. Okay. You need to pause that to copy everything down. I'm getting ready to clear. And finally, the vocabulary and concept check. Make sure that you identify which one you're doing. Complete sentences. Remember, you're the mathematician. Write mathematically. If you have any questions, please leave those. And have a great night. And I will see you in class tomorrow.